In this video tutorial, I will talk to you about the semaphores and how to use semaphore in this task. So here we are going to use fork in order to fork multiple child processes, in order to get multiple child processes, and then by using semaphore we will experience that how child processes will use the shared resource with the help of semaphore. So as you may know already, if semaphore is just we can say that it's just a variable, and there is semaphore value. If the value of semaphore is a positive number, let's say that there are three, the value is 3, it means that three process can concurrently access the resource. But and there are two functions, same weight and same post. So every time the process or the thread calls same weight, it decrements the semaphore value, and then after it calls same post, it's like it releases the semaphore, so it increments the semaphore value. So let's say that we have set the semaphore value to 1. It means the first thread or the first process that calls same weight will decrement the value, so it's going to be, the value of the semaphore is going to be 0, and then it means that no other threads or processes can access this semaphore. So if it is 0, the process or another waiting process will block and will wait until the current process or the current thread increments the value of semaphore or releases the semaphore, so that after same post is called in the current thread, it means that the next thread is ready to be processed. And the negative value, if the value of semaphore is negative, so we can say that the absolute value of this semaphore, so let's say that the semaphore value has got -3, it means that there are 3 processes waiting to be processed by the CPU. Okay, so I hope semaphore value is clear for you now, and then now we can continue coding. So these are the necessary headers that we have included. So you will see them. You will see some functions, some data types that we will use from these libraries. So firstly, I will declare some variables, some useful variables. As I told you, I'm gonna use a for loop, so I want I to be declared here for the for loop. And then yes, here I'm gonna use shared memory, so I will attach a variable to this shared memory, and then I will initialize it too. And then by using fork function, I will let the different child process to access the shared memory segment and to use this or to change this value in critical section. Okay, so for this purpose we will use shared memory, and I'm gonna create a key for shared memory, and of course there will be shared memory ID as well. And so I want a shared value to be stored in this segment. And another thing I want is yes, so here as I'm using fork, I will declare it as Pete here, and I want fork count as well, so I'm gonna declare as fork count, and semaphore value, so I'm going to declare it with unsigned int semaphore sem value. Okay. Then I'm creating a key for I'm creating key for the shared memory, so I can use any just file name, path name, and any number, let's say 65. Okay, it should be shm underscore key, and then shm id will be get through shm get. So shm id first argument, size of, so here I'm declaring it as a size of int, as it will be integer to be stored there, and as a flag, so I'm setting permissions and IPC create. After creating shared memory ID, so I can check if shared memory ID is okay or not. So if it is less than 0, it means there's something wrong with maybe shm get, and I do exit with exit failure. Okay, and yeah, I do exit with exit failure. Then what I want is to attach this shared value to this shared memory address. So what I'm using is shm at function. First argument is shm id. Second argument is address. If I define it as null, so the shared operating system will allocate any address, any suitable address for this memory segment, and then I will use I will initialize the this value, shared value, to 0. After that, I want user to enter how many fork he wants. So I'm writing how many fork do you want, and I do scanf the fork count. And so yes, I haven't created after that I wanted to initialize semaphore, but I haven't created I haven't declared the semaphore here, so I'm using so there are two types of semaphores, named and unnamed types. So here I'm using named semaphore. So for named semaphore, we are using semopen, and the first value is gonna be the name of the semaphore. So I can create it as semaphore, simply just semaphore, and the second is flag. So I'm creating as create or X. So it means that if there is no such semaphore, create it. If there is, just use it. And then I'm setting the permissions for this semaphore, and I'm passing the semaphore value as well. But firstly, I should ask user to enter the semaphore value. So enter semaphore value and scanf. It is an unsigned integer, that's why %u is used. Sem value. Okay. What's wrong here? Oh my god, yes, it is a pointer. So now it's okay. Now we have initialize semaphore as well. What we can do is we can go to fork process. So I will fork I will fork how many times the user wants to fork, and so here I will write pid is fork, and if pid is less than 0, so there is something wrong with fork. Yes, we can do. And after that, what I want to do is unlink, use some unlink function to immediately remove the semaphore, and same close function to free the resources that the operating system has allocated for this caller process. Okay, and here I'm passing the sem as an argument, and yes, and I can exit with exit fail. Okay, and after that, if I'm checking else if pid is equal to 0, if it is a child process, I want to break out of the loop, because otherwise I want to, for example, if it is 0, it means that the first child will be will come out of this for loop. So I wanted to break out of loop and do something on the critical section. Okay, that's why we are using break here. And then I'm checking. So if pid is equal to 0, it means that this is a child process. So child process. If pid is equal to 0, so here first I'm using same weight. As I told you, same weight will decrement the value of semaphore, and we can write printf child. Which child is in critical section? We can see it by using this line. So then I will use here sleep, because otherwise we will not feel how semaphore actually works. So I will show you, I will uncomment and comment it, so you will see that why we need to use this, why I'm using this. So in this part, so which is called critical section, so what I want is to actually increment the value of the shared value by I multiplied by 3, and after that I can print that child, for example, I, the new value of shared value is equal to I and shared value. Okay, so so the critical section is over, so we can use sempos to increment the semaphore value, and then we can simply exit with exit success. Okay, and then for the parent process, or we can use else if pid is greater than 0, which is parent process. Well, firstly, what we want to do is to wait for all children to exit, and then remove the semaphore and close it. So to wait for all children to exit, we are using waitPid function. First argument -1 means that it will wait for any child process to finish, to terminate, and so that this can be used for any child to terminate. And then we check if no is equal to a child, which means that this line means that there is no remaining child. So if there is no remaining child, we simply break. Okay, and after break, what we want to do is we can simply print that all children exited, and then we detach the shared memory value from the shared memory address, which is shared value, and we delete this shared memory segment with shared memory CTL control function. And after that, we don't forget to use semunlink, which was the semaphore, and semclose functions to so let me comment it here. So it frees resources, and this one removes semaphore. Okay, named semaphore. And then just that's it, and we exit with 0, which is success. Okay, so now we will check it. So you will see. So to check it, I'm gonna use sem and pthread as well. So sem, and how many fork? For example, 3 fork, and entered semaphore value. So here I'm gonna enter 1. So in this case, it is a binary semaphore. So when I enter 1, it means that the first child process will decrement the semaphore value, which will be 0 after decrement. So it means that no other thread can access this resource concurrently with first child. So after first child releases the semaphore, so then the next one can access, and then the next one. Okay, so this is release. So here I'm entering 1, child 0 is in critical section. As you see, the processes enters one by one. If we don't use sleep here, we cannot feel it. That's why I'm using sleep there. We're gonna 3, 1, 3, 4, and if I do 1, so yeah, it happens quickly, so we don't feel it. But I'm gonna uncomment it, and this time I'm using 3 for fork and 2 for semaphore value. I hope you can guess that. It means that 2 processes can currently access the semaphore resource units, semaphore resources. So you will see 1, 2, then 0, 1, something like that happened here. So here the shared value actually is, it can have unexpected behavior, so we can run it one more time to see it. So 3, 3, 9, so we can have such so for example, if I change it to 3 and 3 at the same time, so we have 0, 3, 9 as output. So if I change it 3 and 5, so again there is no problem. But if I change it to 3 and 2 again. I just want to change it. As this time we can get 039. Okay, I hope I could explain something to you. And for the exercises, I will send you an email, an explanation email. Okay, bye bye.